Oh, nice, the clips. Part of the point of JS hard parts is to go under the hood of the language a little bit, so that we understand how things are really working, so we have a good mental model, so that when we encounter something new, we're able to go and race our way through it because we can see what's really happening. Not only that, we're going to map through our code with incredible precision, line by line, and that mental approach, that technical communication, which we found was the best predictor of the highest salaries out of Codesmith, is again a vital part of what we're going to be doing today, mapping through our code line by line with enormous precision. Thank you, Jessica.
Hi, my name's Don.
Hey, Don.
This is my second shot at learning JavaScript.
Sweet.
Read some books. I play around with a lot of, jQuery, some frameworks, with websites, doing animation, but I really want to get it down. Done some the Code Academy, but I guess I really need to really just be working on problems.
That's it. Leveling up from knowing your syntax, having your head around, like feeling intuitively what a for loop is, feeling it's like what is a function, feeling those things intuitively. You've got to go from that to where you autonomously start to solve real problems with code. Now the easy way of doing that is just code-a-byte, code wars, algorithm challenges, or coding challenges. That's great, that's fine. The other way, which I personally love, is building a Chrome extension. My dad's actually a school principal, believe it or not. He said, never teach. So there we go. Mistakes are made. Building Chrome extensions. I heard a few people say I'm doing a full stack Angular application, that's fine, but there was actually a thing on Hacker News today, building a React application from scratch. And a lot of the commentary from Hacker News elites, a little bit snooty, these people, was still saying, there's so much boilerplate code to get started on. That does not enable you to problem solve. When you say, I'm going to go build a React application, or it's very glamorous, maybe an Angular application, you're going to spend a bunch of your time copying and pasting bits of boilerplate code from tutorials. That does not make you a problem solver. I worked out why we don't teach HTML, CSS. We expect you to do it by yourself, by default. I worked out why. I hope I already knew, given we made that choice at some point. But this is the reason. JavaScript or programming, if I understand, to understand this piece, or to use this piece of knowledge, I need to have a sense of the 30 adjacent pieces and link them. It all builds upon each other. That requires a real growth in your versatility to approach new problems and pick this block, and then this block's going to join in with this block of knowledge or approach. HTML, CSS, if you want to make something go to the left of the page, to some extent you just search how to make something go to the left of the page, and it's maybe 2 or 3 words that will make it go left. And then the next thing, which could be make something have a border, it didn't matter that you knew now how to make something go left of the page. It's not going to really play much of a role in adding a border to an element, which means you really can and should not learn it as you go along, but a little bit of that. Whereas with JavaScript and with proper heavy lifting programming, these things all play into each other, and therefore you really have to level up and start problem solving with code and take it, okay, for this problem, I need to take these pieces together and wheel them together. And it turns out, in my view, the best way of doing that is building little Chrome extensions. Because with a Chrome extension, you can write one with 15 lines of code, 15 lines of JavaScript. And you can solve a problem you have every single day. One of my favorites, which I've now been lightheartedly mocked for by my team for bringing up every single time. And then also referencing the fact that I bring it up every single time. So now I'm referencing that.
You can do that next week and the week after that.
It's going to become recursive how many times one of the attendees is JS Hard Pass. Wonderful guy called Curran. He built a Chrome extension that when you loaded Facebook or YouTube or BuzzFeed, it pops up a little window saying, are you sure you want to open Facebook? Here is a list of your to-dos. Go do those. And he did that in 15 lines of code. And then he said, I really wanted to make it work on this site. And so you have to go and iterate on his code. Now he's wielding code as a tool to solve an actual problem he encounters every day, as opposed to building an application, the standard to-do list application, that it's very artificial. Build something that solves a little problem, but don't try to build a full application. It's too much boilerplate code. Instead, the magic of Chrome extensions. Few lines of boilerplate, the rest is you solving problems with code. So I highly encourage that. All right, long aside there, but now my friend here. What are you up to in JavaScript?
Hi, I'm Charles, and I love JavaScript, and I just started Free Code Camp around 2 or 3 months ago.
We love Free Code Camp. This is a fantastic resource. One of my favorites of all. Huge shout out to Free Code. Who's using Free Code Camp? Raise your hand now. Oh, well, I strongly encourage all of those using Code Academy, explore Free Code Camp. This guy, Quinton Larson, I don't know how he justifies what he's doing. It's unbelievably high quality stuff, and all for free. Really recommend it. Hello.
Hi, I'm Jen Diamond.
Jen.
Yes, Jen.
Lovely to have you here, Jen.
Nice to have you. And nice to be here.
Jen, you're so welcome.
I mainly work in Ruby and Rails,
Okay.
and pretty much can't have a job without knowing JavaScript these days. So I've done a little Ember and a little bit React.
And which resources particularly excited you in JavaScript? Do you like to share?
JavaScript I've been doing through JavaScript LA, some classes on the weekends.
Nice.
And
A guy called Vic.
VJ.
VJ. I know VJ very well, so I apologize to VJ.
Yeah, and I came here for the Node School.
Nice. I love Node School. Nodeschool.io. Great set of challenging resources. If you can bring yourself to tackle them, best to do them in a pair because they are tough. It is worth doing.
And
All right.
I do the Euler or Euler.
Project Euler, yeah, whatever. Euler. Let's go with Euler. So, what is Codesmith? Codesmith is one of those hundreds of boot camps that we all love. But we're going to explain what makes a world-class boot camp. And by the way, I think there's a couple that are this, and talk about that very briefly. But first, who am I? Will. CEO, not CTO. I actually changed 11 months ago, but I never changed these slides. So there you go, co-founder CEO of Codesmith. Codesmith, the master's program of coding boot camps. A quote from one of our hiring partners who's made offers to 3 grads, I believe, but 2 are now working at Whisper. He's CTO there, Chad Depew, wonderful guy. Now just joined as VP of Engineering at Snapchat. So we all know Snapchat. Now we're recorded online. There are certain things I can't say about our aspirations of Snapchat being a hiring day, and so there we go. That's the joy of being online and permanently recorded. But the master's program, what does that mean? That means you must be at the level. We get a lot of applications from people who've been through other boot camps who want to level up, who are already able to get a junior developer job and want to come out of Codesmith getting a mid or senior role. What does that mean in practice? It means that from the last cohort that has graduated, probably now more like 5 weeks ago, 4 or 5 weeks ago, all but 2 of them, I believe, have offers for an average salary of world record breaking $111,000 right now. Now, we're going to put that on the front page of the site? Yes, tomorrow. But we're not sure because I think it's never going to be that high again. This is really crazy. I don't know if ever be that high again, which means it's going to be a bit demoralizing as we have to put a lower number for the next cohort. But whatever. Right now, real shout out to them. They've done phenomenally well from the last cohort. So, this was the hiring day. This is the hiring day that they were all at. So all these companies, and it really cycles through. So right now, very excited for the next hiring day. 2 weeks in advance, we already have 25 hiring partners locked in. That's the highest by far 2 weeks before hiring day, believe me. Normally it's make sure we bring them all in the last week, but we're very excited. So these are all the hiring partners from the last hiring day. They all come on site. They see the graduates present their projects, their major projects, and then the graduates each do 10 to 12 one-on-one interviews with the hiring partners they're most excited about. And those projects are not bootcamp projects. This is a big, important, significant thing. As the VP of Engineering at Ticketmaster said, these are projects, quote, of significance. Things that are now being used in production, collectively with thousands and thousands of GitHub stars. I mean, they're really engaged with by the developer community. Because you've got to come out of this program as a seasoned engineer, which means you have to build projects that seasoned engineers would build. That's one of the biggest factors, I think, that gives the grads such credence in the work. There you go, that was the last hiring day. Everyone having a wonderful time. Companies loved it. That's it. That's it. No, what makes a world-class program? I have to share this with you because, I don't know why. 3 things, I believe, make a world-class coding, whatever you want to call them now, immersive, advanced learning program. You want to call them different things to try and get away from the bootcamp word. What makes a world-class? 3 things. 1, total dedication to every single student. This is hard to pin down, but I was very lucky. For my undergrad, I went to Oxford, and there were 24 of us in my college at Oxford, and 6 professors. And when one of my classmates, good old Henry, I might send him this video afterwards, good old Henry, he missed his first tutorial. We don't do lectures at Oxford, we do 2-on-1s. You and a partner with a professor every week for 2 hours. My favourite professor, Walter Matley, is still a big part of my life, and Henry missed one of his first tutorials. All the professors got together with him and said, Henry, dude, what's going on here? How can we fix this? How can we give them a platform? How can we make you truly excel? And he went on to come second in the whole year at Oxford. And that devotion is what we try and do here. So it means multiple resume iterations, it means many mock interviews, it means a little example that I do reference because I think I'm very happy for Ben. One of the grads got an offer from Ticketmaster, great offer, and turned it down actually. Personal reasons, he had to be in San Francisco. And he turned it down, but 2 weeks later realized, I really want this. Tried to reach out and didn't hear back because companies don't love it when you turn them down and then come back 2 weeks later. So we gave a call to the CTO, and he's now been there for 4 weeks, and he's absolutely loving it. And that's what total dedication looks like to every single student. But I'll tell you this, there's another program that's attaining that same thing in San Francisco. I used to name it, I've been told to stop naming it, because that is just crazy. So we will not name it. But number 2, a very special community. Giving, caring, aspirational, for sure, technically highly gifted with a high potential. There's Stanford mechanical engineering undergrad and masters in the program, but there's also people who are not from an engineering background, many, philosophy background, psychology background, but they're all devoted to growing each other. And for sure, it's a selective process, about 1 in 12 to 1 in 15 people are admitted. But most importantly, along with them having technical potential, they're all just the most down-to-earth. This guy here made a great quote when I sat with him and said, Sam, how would you characterize Codesmith's community? And he used 2 words that he now wants to get paid for every time I reference. 1, brilliance, no doubt. 2, playfulness. That notion of people wearing their talent lightly, not swaggering with their talent. There you go. That's number 2. Number 3, making people software engineer problem solvers, not technicians, which means we can make our lives so easy by teaching you how to build an Angular application in this particular way. You feel so good, I've learned Angular. That is not true. Instead, we explain, or we go under the hood of why does Angular exist? What's the design purpose of Angular? And then, in your pair programming, you work through the challenges and build an Angular application. But grads have gone on to do Python or Erlang, or work with Ember rather than Angular. The frameworks, the languages, we have to be agnostic to that. We have to produce engineers who can tackle any new technology. And that is very, very vital. And again, I tell you, there's another program that does many similar things to this. All right, good. Enough of that. For now, we are going on to, let's try and embrace our online friends. For now, we are going on to JavaScript, the hard parts. Part 1, callbacks and higher order functions, or how to become a functional programming star. So, functional programming is very on trend. It's burgeoning right now. More and more popular. Anyone know what functional programming, characteristics of functional programming? Yeah, go ahead, dude.
You don't save any states?
Mm-hmm. Yes, let's give any other definitions. Go ahead, Carl.
Runs asynchronous.
Asynchronously?
Yes.
It's both interesting. Let's focus on 2 core features of core functional programming. One comes from Lisp, one comes from Haskell. One is functions can take in as inputs other functions and pass out as outputs other functions. Okay, we're going to see what that looks like. Number 2, functions are pure. There's no definitive definition of functional programming, but functions are pure means, I'm going to see what all this means. Functions are pure means when you run your function, it has no unexpected side effects in your code outside of what you explicitly state as the output of the function will be. These are 2 core principles. We're going to see that higher order functions and callbacks are vital parts of the functional programming paradigm, one of the most popular ways right now of structuring our large-scale code bases. When you're writing lots of code in one go, or big applications, you need to start structuring it in some way, giving it some sort of predictable form. And functional programming is one predictable structure we can follow to make it easy to test, to write checks to make sure it's working right. That's what tests are, to make sure it's working right. But also so that other people can pick up your code and go, okay, I understand how this is going to be laid out. And the functional programming paradigm is becoming more and more popular as a format for doing so. In the short term, it allows us to build some very nice array methods. So why do we care about higher order functions? We care about them partly because they are in Codesmith's interview process. But we also care about them because they allow us to, well, we'll see. They allow us to do some interesting things to arrays and lists. Good, the longest opening to JS hard parts of all time, but we'll live with it. What is a function? Let's go and have some suggestions. Peyton, what's a function?
Function takes an input and spits out an output.
It might do, it may not, but it might do for sure. Alejandro, what do you think a function is?
I mean, it's just something that, like a block of code that you want to do over and over again.
That's pretty nice, Alejandro. A block of code you want to do over and over, you want to execute, you want to run over and over again. I like that. Hey, we've been here too long, so we're going to... A set of instructions to perform a specific task. When we write code, we're just writing instructions for our computer. Go do this stuff, go run this stuff. What we're saying here with a function is, here's a set of instructions, bundle them up so that we can maybe give them a name to refer to run over and over and over again. Perfect. They may have an input, they may have an output, they may not. All right, good. So now, JavaScript the hard parts begins, and we are going to map through our code here. And it's going to feel, for some of you who are more experienced, a little bit procedural. It may feel, I know how this is going to work. We're going to map through with great precision. The way JavaScript the hard parts works is we all get ourselves up to a baseline of understanding of something which is fairly manageable. Then we go into our pair programming, where we'll start to be introduced to the more tough concepts. And we're going to come back and use the same approach we did with the easier stuff for the tough bits, so the tough bits just kind of flow very naturally. All right, here we go. So, define versus running function. We're going to start walking through this code line by line. And who shall I have first? Jen, go ahead, kick us off. What are we doing in the very first? We're going to play here the JavaScript in. I'm going to manage my audiences here. We're going to play here the JavaScript interpreter. What it does is, we're going to play along as a computer does. It reads our code line by line and says, do this thing. So this says here, JavaScript reads this and goes, do whatever it tells me to do. And we're just going to play that, and we're going to discover we cannot go wrong when we follow this process. So Jen, kick us off. What are we doing in our very first line here?
We are defining the function multiply by 2.
Excellent. Now, when we define a function, where does it go? JC, where do we put a function when we define it?
Local storage.
Local, just more generally. Where is it?
.js file.
Who said memory? Yeah, exactly. You're exactly right. So, just as if I were to define a function, sorry, a variable var hello equals world. Oh, do this. Hello. How can I retrieve hello back later on? Well, I can retrieve it back because it's stored in actually what's known as my global memory. There it is in my global memory. And what's it stored as? Well, hello is our label, and assigned to it is our string, our word, world. Okay, there it is. So we, by declaring a variable, we stored it in memory. We're going to map through that. We're actually going to map out our memory as we go line by line. So actually, what's the very first thing in that memory, Jen?
Is the function multiplied by the
Absolutely.
name of the function.
So the label is multiply by 2. And what's stored in that label? What's stored assigned to that label?
The parameter number.
It's the contents of the function.
Yeah, the whole function. The whole function definition. That whole thing. The arguments, that's the inputs. The body, that's the bit inside it. But it's the whole function. Meaning, we could refer back to it later on.
And it will run.
It'll run that whole function, exactly. So the whole, now I draw functions here as a little box, like you did at high school or at college, you know, as a little sort of input, output, like a black box, as well as our whole function body here. Okay, good. Now, next line of code, Jimmy, we've hit the first line, we said declared function, grab the whole function definition, stored it in memory. What's our next line of code that JavaScript is going to encounter?
You will replace the number with number 10, and you will multiply 10 by 2.
It's not far off, to be honest. What's our actual next line? So Jimmy's essentially saying, what's Jimmy saying here? What's our actual next line of code we hit, Peyton?
Calling multiply by 2.
This is really important. We do not hit this line of code here, return number by 2. What does it take for us to encounter that line, JC? We have to invoke the function. The JavaScript hits our first line and says, grab it hits the curly brace and goes, I'm going to grab the whole function, store it in memory, and I'm just going to leave. I will never hit the lines of code inside of this function if I don't run that function. I will never. There are 2 clear stages to every function. Definition stage, where I grab the whole thing. How do I spot that we're defining a function? Alejandro, how do I know we're defining a function here? What's the key word we've got at the front? Function, yeah. It's really that explicit. It says function, we're defining our function. We do not go inside that function unless we invoke it, we call it, we run it, whatever you want to call it. So there we are. Let's do that. So let's start running our function. Multiply by 2 is run with the input of 10. So now we start executing our function. When we start executing a function, who knows what we create? Kyle, what do we create when we begin executing our function?
An execution context.
Exactly right. An execution context. Sounds highly profound. What we do when we're writing code, when we're reading through our code, is 2 things. We have a store where we throw stuff into or get something out of, right? We've seen that as a global memory, our sort of live store of variables and values, like a live place where we go and store stuff as we go through our code. And what's the other thing? Well, it's the process of going through our code. This process of going through our code line by line, reading through it and doing whatever it says, is called our thread of execution. It's our thread. It's our doing stuff. We go down, we read through code by line. It's our thread. JavaScript is just going through it line by line. When we start executing a function, we do something very powerful. We create a brand new execution context that has inside of it its own little baby local memory and its own little thread of doing stuff. I.e., we stop running our code outside of the function and we go inside and start running our code inside of our function. And we get to create a little local version of what we had globally inside of here. So suppose inside of this function we had the word var hello equals 3. Who shall I ask? Pablo, sorry. Pablo, we had inside of this function var hello equals 3. Where would that hello and 3 be stored? In the local memory. What do we got here in the global?
The function.
Yeah, exactly, spot on. So if we had so that's all we're doing. We have when we start running a function, executing a function, we create a brand new execution context. By the way, when we finish running this function, this execution context dies. It goes. All right. So let's go inside of multiply by 2. Even for something as trivial looking as this question, we have to go through line by line and map it out because it's going to make the hard bits that come so much more manageable. Tom, we're inside of the function. It's not hello is 3. What's our first thing we're storing in our little local memory, Tom?
The argument number.
Paired with?
2. Wait.
What's it paired? What's the number now? We're running this code. We are every single variable has a value inside of this function. There's nothing just like number is something now. What is number inside of this function?
10.
It's 10. So our very first thing in our execution context, local memory, is number is matched with 10. Okay? Which means when we do return number by 10, we can just look across return number by 10. We just look at what is number? Oh, not by 10. No, by 2. We look across, what is number? It's 10. 10 by 2, 20. And what are we going to do with that 20, Tom?
You're going to return it.
Exactly. So that means that this multiplied by 2 with the input of 10 is going to become the output from this function. Whatever's after the keyword return is going to, and who knows the posh word for becoming the output? What do we call that? Andrew, do you know?
The output?
Anyone know? This is going to evaluate to. Okay, it's going to evaluate to this output. So output's 20, and this whole portion here is going to evaluate to whatever was after the keyword return when we ran this function. So out comes 20. Will, how do we hold on to this 20? Do we have access to this 20, or is it's kind of lost in the ether? So what can we do with it?
You can multiply it by anything. You can do anything with it.
How can we hold on to it, though? How can we sort of save it?
Well, it's in the thread, right, or the global memory?
Is it in the global memory?
No, but
It's in the global, exactly. We're out in the global thread for sure.
Yeah.
So our execution multiplied by 2 with the input of 10 has evaluated to this block here has become that 20. How do we hold on to it? What?
Bind it to the variable.
Yeah, exactly. We have to bind it, we have to assign it. Those online cannot see the incredible setup we have here with the chair, the stability of this system here. Good, exactly. Assign it to some variable. So the result, because we know the result of executing this function is going to evaluate to 20, and then it's going to become that 20. We stick that in a variable. So now in our memory we have result is that 20. We declared a variable. We said JavaScript go away and find out the result of running multiply by 2 with the input of 10, create a brand new execution context with its own little thread, its own little local memory. Whatever it returns out, this multiply by 2 with the input of 10 will evaluate to that what's called return value. This 20 is the return value of running multiply by 2 with the input of 10, and then stick that result under the label result. All right. This may seem incredibly procedural to some of you who've been coding for a long time, but this level of precision here is what's going to make the hard bits just flow so naturally. Okay, so at this point we're going to have thumbs, a traditional education practice. I have no idea what just happened. I have some clarifications. I want a phrase, and for a question, my clarifications. I am so clear, I am ready to move on. Everybody's thumbs out at this point. Okay. Irvin. Ivan. Irwin. Sorry, man. Irwin, what's the clarification?
Okay, so just to get this straight, right? So that 10 is being inputted by the user, right?
Oh, we wrote all this code. We wrote all this code, but we're reading it through as the JavaScript interpreter. JavaScript interpreter is the name of the computer going and reading through our code and running it. The computer runs the code we wrote. We wrote all this code, and now our JavaScript interpreter is reading through it line by line and going, okay, it's saying do that, I'll do it. Do that, I'll do it.
I think he means though, like, yes, number is being replaced by the number 10.
No, I was just wondering, like, okay, so that's the random code that you wrote, right? So, but is the 10 being inputted, like, for example, like you wrote the code, right? But is it inputted by me? Like, for example, if I'm using the website, or is it still being interpreted by the
Okay,
code?
I see. Let's hold that question about. So we are writing this code as the developer. We are not a user at this point. We're the software engineer writing this code. It's going to then separate in your mind this from what you sort of see as a website, a UI website, sort of the view. We're writing this as kind of almost
So
as a
you're
developer.
only talking about the back end part. You're not talking about the UI.
Let's
part.
call it that. Let's say that.
Okay, that makes
Fair point, Yoan.
Alright.
Right.
Where is the execution context stored?
Oh, great question. That's a lovely question. Okay, I try to avoid bringing this up, but we're going to bring it up. Every now and then I bring it up, but I have something to do. Something called the call stack. There we go, the call stack. So we start off when we're running our this is JavaScript's way, the JavaScript interpreter's way. So this is a little bit of a bonus for some of you folk who are a little bit more new. For those of you who are a bit more experienced, you may even be familiar with this, but when we start running our code, JavaScript needs to know, am I out here running code globally, reading through the line by line out here, or should I be reading through the line by line inside the function? It needs to, I mean, it doesn't invent this, it needs to know. And the way it kind of records where it should be reading code, is using the call stack. So it starts off, let's say, running global function, so it starts off this level. That was running through the whole global level code. All right, we're reading this bit out here, we're not inside the function. When it starts executing a function, creating a brand new execution context, it actually throws a new execution context, like a new combination of memory and running on top. What was it called? We're running multiply by 2, right? Multiply by 2, it throws that one on next, and we stop being inside this one, and we jump up here. When we hit the return keyword, this dies. This is finished. And we go back out here. That's why anything we create inside of here, we have to return out to get back out here. And you know what? This execution context, done. We finish with that one. We go back to the global one. So it's stored on this thing called the call stack. Does that answer your question, dude? All right, good question. How about that? Opening with that in your, very good, first 10 minutes.
Does it have garbage collection?
Does it have garbage collection? Yes. JavaScript automatically handles. This is a question of, if you create a bunch of things inside of your function that take up lots of space in memory, because everything you define, everything you create, all the words you save, they all take up space in memory. In the end, you're going to run out. If you stop running a function, you're never going to use that stuff again. That's known as garbage. Some languages we have to, by hand, say, okay, I've finished using this function or this variable, close it off. In JavaScript, it's going to automatically be cleaned up for you. It's going to automatically delete anything you're not going to use. There you go. There's some pretty advanced concepts for our kickoff. But good questions, everybody. Now, before we go any further, before we move to the before we move to our pairing, we'll come to it a little bit later, Jess, I think. Before we move to our pairing, we're going to create a function, 10 squared. This may feel even more trivial, but it's going to allow us to see where our higher order functions come from. We're going to start off by creating a function, 10 squared. I've got these little lines on the floor here to keep me in camera view. So I like to stand just here, just outside of the line. Am I in camera view, Sam?
Yeah.
Oh, I am.
No.
No, there you go, exactly. Let's stand outside the lines. Good. Okay. Ruby, actually no, not Ruby, Angel. Angel, what's a function that's called 10 squared, takes no input, and returns 10 by 10? What's the syntax? What's the way we'd write that?
function.
Yep.
You'd say function and then whatever it is you want to call it, which is 10 squared.
Makes sense, yeah.
And then no input, so.
Sorry, I need to repeat these. So function, we're calling it 10 squared, and then no input, so.
Open and close parentheses, nothing.
Little parens with nothing inside, yeah. And then.
You open your curly bracket.
And then what's going to be inside?
Everything you want the function to do.
Which is?
In this case, it returns 10 times 10.
Yeah.
10 squared.
Angel's just surprised by how useless this function really is. But it is true. It returns 10 by 10. Good job. Now, a harder one. Nah, this function is called 9 squared. Tara, how do we create a function 9 squared? What's it look like?
It would look exactly like the 10 squared function, but with 9 times 9 is the expression.
You're so right, Tara. There it is. Oh yeah, that's the function 10 squared. We call it, with no inputs, it returns out 100. You know, same thing here. Function, and maybe we want to create a function 100 squared, 356, whatever it might be, 65, 256, whatever it might be squared. We're creating a brand new function for every single one of these to get the result of squaring a number. We're breaking some principle. This principle called DRY, dry. Who knows what that stands for? Everyone together? This is an advanced group, exactly. Yeah, indeed. And there must be a better way. What can we do, JC?
You can take an input.
Right, so we could say, leave as a placeholder when we define the function what the data is going to be that functionality is being done to. So the functionality is times two numbers together. But we're deciding when we define the function what that data, what we're timing together, what multiplying together is. Instead, we could say, leave that as a placeholder, pass in as an input, only when we execute the function, decide what we're actually going to be multiplying by. So we can generalize our function, call it square num, and pass as an input num, and then return num by num. That's our definition. Then when we execute the function, when we run the function, that's when we decide what our data is going to be. Very powerful, because now we write our functionality once, and we can use it again and again, and we can pass in our data only when we execute the function. We don't need to create a brand new function every single time. This is profoundly important, and it's going to come back. We're going to discover we may not be only generalizing for our data, but we may also be able to decide some of our functionality when we execute our functions, not just when we define them. So we've decided here, when we execute our functions, that's when we're going to determine our data, not when we define them. It may be that we can decide more than just what our data is going to be when we execute, but something else as well. And that's going to be the backbone of our higher order functions. But first, we're going to move into the true fun part of JavaScript, the hard part, our pairing. At this point, I sometimes like to shout out some of our online viewers, but maybe we'll do it afterwards once we know who they are. Right now, they are not in my phone, so I don't know. But nevertheless, we're going to jump into the pair programming. The pair programming is what we're going to talk about in a moment. First, see this list up here. I know what a variable is. I've added the CSS style before, I understand callback. Give yourself a score out of 7 on these. If you know all 7, you're 7. If you know 4 of them, you're 4. And then grab your machines. We're going to stand up. We're going to line ourselves up around the room with those with experience of 1, 2, 3, 4 over here. So if you know what a callback function is, you've created a function before, you know what an object is, but you don't know anything else, you're a score of 3. So you're going to be about over there. If you know all 7, you're going to be over here. You're going to line yourselves up around the back, and we're going to pair you off for the pair programming. So everybody stand up.
Where are the fours at?
5 over here, 4's over there, 6 is here, 7's here, 3, 2, 1 over there. Nice.
Oh, there's more space here.
Yeah.
Huh? No. Five's over here. Fours are here.
It's trying to change the rules.
Self-organization.
There's only one teacher here.
Self-organization. Oh my god. This is not emergent leadership. Dictatorial leadership. Go with that. Emergent leadership. Alright. Good. So everyone over here thinks there's 1, 2, 3, 4's here, about 5 here, about 6 here, about 7 here. Alright, 6 or 7's here. Okay. Tom, Peyton, you're together. Kyle and Kevin, sorry, the two of you together. Jen and Will, the two of you are together. JC and Pablo, the two of you together. Ruby and Charles, sorry. Owen and Jason, the two of you together. Henry and Raphael, the two of you together. Jimmy and Dawn, the two of you are together. Angel and Andrea, the two of you together. Ben and Veronica, the two of you together. Three of you guys are over here as well. Oh, did I not get Jessica? Okay, Jessica, you're in that group. Okay, grab seat to the bottom. That's my only skill. And I don't maybe someone goes to me, what sort of goes Alright, Andrew, Jessica, we're going to go grab some. Alright, everybody. So I have 3 things to share. But we briefly went to 4, and I can't think why I went to 4. I wonder what that 4th thing was now. You remember there was 4 things once? 4 things to share. Oh, probably Wi-Fi code. 3, okay, 4 things to share. Number 1, I want everyone's attention because this is vital, and you don't need to be on Codebyte at this very moment. Shout out to Codesmith. Oh, yeah, nice.
24 products per month.
24 what?
Products.
Oh yeah, we have a bunch of Codebyte, free Codebyte, and we partner with Codebyte. They put a bunch. I think they're really good. This is a great preparation for you leveling up as a problem solver, not just being a syntax or tutorial follower. And so Codebyte is a great resource for that. And so they gave us a bunch of free accounts because they now cost $24 a month, which is legit because they're actually very good. That guy was being very generous. He costs a lot to host, so it's now $24 a month. And he gave us a bunch of free accounts, so give any of the team an email if you want one of those free accounts. We're going to buy it at some point. Especially if you're friendly to me at drinks afterwards. You get guaranteed Codebyte accounts. Codebyte account for you. For you. For all of you. Oh, my hope for a moment at last. Good. 3 things I want to share. 1. What is this pair program? Raise your hand if you've never paired before. I want to see you've never paired before. So I show a lot of new folk to pairing. We look at 5 factors. Alright, laptops pull 2. So this is a vital piece. Laptops pull 2. That means a laptop. Thanks, Alec. Thanks. Did you pull your laptop too? We look at 5 factors in the Codesmith interview. Number 1. Analytical problem solving with code. How do you navigate through a problem? Number 2, technical communication. How do you talk through your code precisely and clearly? Number 3, non-technical communication. Are you a thoughtful, empathetic person who puts others first? Number 4, debugging. Well, engineering best practices. What it means is debugging. It means when you hit a block, how do you navigate through that block? When you hit a block and you're solving a problem, how do you navigate through it? Number 5, the 5th most important factor is your JavaScript experience. Pair programming is like the all muscle workout. And I hate analogies. Analogies is a stupid way of explaining things, but it does feel so close. Pair programming develops all 5 of those capacities. So how does it work? It's a superpower. Pair programming is a magic way of growing as an engineer. So how does it work? There's 2 stages to it. Oh, before we say that, how does it work? When we are learning to code, when we're building and growing ourselves as engineers, we have 2 dangerous tendencies. We have this through the whole career. They don't go away fully. You get better and better at handling it. On the one hand, there's a tendency to dive too deep. You go and you start reading every last thing you can find, and you say, okay, but I want to understand how that bit works. And you don't understand how that bit works. And you never get your hands dirty in the code. Paolo's smiling because we've all been there. We've all had that moment where we just keep going deeper and deeper with that, and it feels like we're learning so much. We watch more and more tutorial videos. We're not getting our hands dirty. It's very dangerous to become extreme in that side. But the other extreme that a lot of people will also relate to is encountering a problem, just kind of making it work. Maybe using jQuery to kind of just join the dots without fully understanding really anything of how you're doing it. Pair programming lands you right in the middle, because you don't put your hands on the keyboard, you have to have your hands almost behind your back, and you're going to explicate, you're going to explain through exactly how your partner has to solve the problem. And then they're going to interpret your very precise, what's called pseudocode, your very precise explanation, into actual code. All right, so let's see this in practice. So 2 stages. The research stage, so you're given a prompt, for example, this is Sam's other favorite thing I say every single time. For example, let's say returning 20 tweets from the Twitter API. I want to return 20 tweets from Twitter API, and he says, and append them to the page. That's a challenge you're given. Let's say that's a challenge. And suppose we're JC and Pablo, and JC and Pablo goes, do we know how to do this? Not fully sure. Let's go and look at the Twitter API and see how it says to solve the problem. How does a GET request in Twitter API work? So they go and research it, and then JC says, you know what, I've got a sense. Do you mind if I'm navigator? And so Pablo's driver. And so JC now says, okay, almost hands behind his back, says, all right, Pablo, so we know the tweets are returned to us as an array, a list of strings. So let's create a function, declare a function, append tweets. It's going to take as an argument, as a parameter, tweets array, which is an array of strings, array of tweets. And the function body, let's iterate through the array of tweets we passed in, and let's take each tweet, and using the jQuery append method, let's append to the DOM element with the class name tweets container. And then Pablo is going to go, all right, got it. Function, very precise, here we go. Function, append tweets, open parens, tweets array, close parens, open curly braces. So his job is to interpret that explanation, that explication of each step into actual code. And that process is so powerful. Now, Pablo realizes JC is going a bit down the wrong path, and he lets it happen. And when they hit the block, because they're console logging and discovering it isn't working, Pablo goes, you know what? I have a sense what might be wrong here. Should we go through line by line? Pablo knows where it's going wrong, but you're going to go through line by line together to hit that block, identify exactly where if you talk through your code line by line, you can't fail, but to identify the bit where you're a bit confused, go and research that bit, bring that new information back in, and then use it. And they're like, utilize is the most pretentious word in the world. Use it. Just use it. You're going to go use it. Utilize. It means the same thing as use, right? But people like to use it because it's so profound sounding. All right. You're going to use that knowledge and solve that problem. That is how you succeed in the Codesmith interview. And after maybe 10, 15 minutes, you can flip it back. So if JC was navigator, now he's driver after a few minutes, or after 10 minutes, or a few functions. All right, any questions on pairing at this point? All right, good to go? Oh, Ben, go ahead.
Can we turn the AC off? It's pretty cool back
There's not a question on pairing, therefore the answer is no comment. Okay, you can have the... I like this as an icebox in this room. Okay, yeah, you can turn it up a bit. All right, part two. Part two, you're going to go, Wi-Fi has been erased from the board. Now there it is. Codesmith and I love testing is the password. And then you're going to have some mentors, some current Codesmith seniors probably. They'll be wandering around. If you hit a block, raise your hand. They'll be making sure you're pairing well. But if you hit a block, raise your hand. They'll come and walk you through. They won't give you the answer, but they'll walk you through line by line together. And finally, where you're going to go for these challenges is csbin.io. csbin.io/callbacks. csbin.io/callbacks. All right, everybody, to the pair programming challenges. Get to it.
Okay, so you want me to drive first?
Yeah, we can just go to the
Sure. Yeah, that's it. That's it. I mean, you can, like, the first three are like super basic.
I don't know what it's simple.
Okay. Oh, do you also have yeah, so I just return it to
it's right there. CSBin.
Ready? Yeah, you have to get that.
I don't know if
That's easy.
I was waiting for the camera, I guess. That's right, I know that's right. Okay. Or you could just leave it that way, that's fine. Just leave it like that. Well, no, we can use it because we're making a map, we're building maps.
Yeah, that's confusing because
this needs
this is why I'm if you do the this is returning you have to change this.
No, right. So build for each, or we're using the for each method that we just built, modifying. Oh, yeah. So we need a parameter for our which will represent, in this case, for map here, our callback function is add by 2, or add by 2. So
the callback's going to be
takes 2 inputs, right?
Give us a
well, we would just use the same one, like right here. So our callback is add by 2.
Why some of you guys already started from
add by 2, it's going to pass it into for each. You have to modify for each here to like
check if it's size or something.
Not necessarily. Yeah, so we're still building our story. So well, this is technically over here. This is This is our placeholder. Because just how forEach takes a callback. This right here would represent that comment. It's technically an anonymous function, so it doesn't have a name, but it's referencing to that show. So it would take, so like add 2, in a sense, it takes a parameter, just like we would need to represent whatever the iteration is for the array. So we would pass in just whatever, like just call it the current element. That's what it's running on. So then we go inside of our forEach, and that's where we would. Right.
Oh, okay. Oh, that's what they're doing.
Yeah. So like with this, then we would use. Use this on our callback function as in reference to that by 2, and we pass in to the reference element, which is our current function. We just need to then
That's what I want to do. Okay, so instead of that, like, so like, we're doing a push, so you don't need to try to go.
see, look at now we got now the other one should be I don't know why we're doing this. If you want these 2 down here, they're like brand new.
Right now,
That's good.
You could, but there's no need to because the initial value is already I guess it's already in there. So we could just now return the initial value that you assigned that in.
The cohort right now. Oh man. So we're taking away what have you been working on? Besides that for each code?
So this interpreter. No, it's just like it's just a console. So you would have to pass a log. You have to pass a log. Because all these other ones that pass a log, they just didn't include it in there.
Oh yeah. Just like on Excel.
Zero. Wait. No.
I was trying to bunch of things. I can't do it. Go to the hard part. Code Academy.
No, why it didn't work because there's no reference to like this right now. This is just an ad. Oh wait, did you just? Okay, I think this is wrong. Let's run it in because that's like. Or just use no.
Alright everybody, wow, half of the senior cohort is here. Thank you, and a shout out though, Alex, Dave, Andrew and Danny. Shout out to them, thank you so much for bringing us and Aaron, sorry, Aaron, you settled in so well there. So subtle and inconspicuous, the pink hat. Alright, thank you gentlemen, and we will get back to the session now. So everybody's laptops pulled to. This word, this Britishism is going to make it to America if it's the last thing I do. Alright. JC, do you mind moving this out? It's the most wonderful time of the week. Like about to read poetry. Thanks, Ruby. So disappointing. Sorry. Charles and Ruby, the troublemakers of the class. Alright, good. So now everybody's attention, we're going to dive into the harder bits. So here's this function, this one here, copy array and multiply by 2. We're going to work through this function line by line, and we're going to have all the pieces we need to understand that. Because I was enjoying the sound of my own voice far too much. Good. Okay, let's have Henry can you talk me through here, line by line, what's happening in our code? Starting off, let's quickly firstly say what is this function doing? Copy array and multiply by 2. It's going to take an array, it's going to take each element of the array, multiply it by 2, and the multiply by 2 version of each element, that's going to be an array of those can be our output of the function. That's our basic thing going on here. But we're going to go through it very precisely, line by line, so that we really see how it works. Go ahead, man.
You define the function with the name.
Define a function, the name, which is?
Copy array multiply by 2.
Fantastic. And when we declare a function, where does it go in our memory?
Global.
Global memory. Okay, so copy array multiply by 2 is the whole function definition, the whole body, the whole function definition, the arguments, the whole thing. Okay, next line of code, Henry.
The parameters
Next line of code,
of
Henry.
the array.
Uh-huh.
With the curly brackets, you create a variable called output.
Oh.
With nothing in it.
It needs to be like a buzzer.
Sorry.
Henry, how do we hit that next line? How would we hit the output, the declaration of that variable output? How does JavaScript encounter that line? So actually, when we hit the curly brace, where do we actually go, Henry?
To begin the whole function.
We grab the whole function. So what's our next line of code that JavaScript actually encounters, that actually executes? Do we think?
Copy array. You call it.
Yeah, Jen's right. No, I wasn't about to say. I was going to say Jen, raise your hand. I thought that's just too aggressive. Jen's spot on. Let's actually have Kevin. So we've grabbed the whole function, so we now hit this line here, the last line. Copy array and multiply by 2, input 1, 2, 3. Kevin, what do we do when we start executing a function?
Create an execution context.
Spot on. Okay, let's create that execution context. There it is. Pen's not quite good enough. Oh, lovely. Copy array multiplied by 2 is being executed. So we're executing copy array multiplied by 2 with the input of 1, 2, 3. Thank you, Kevin. And so we go inside. So we now got to go and actually go inside that function and start doing some work. So what do we do when we go inside the function? What's the first thing we do, Kevin?
Stores the variable array as 1, 2, 3.
So in our local memory,
Yeah, local memory.
in our live local memory, so we've got to be as precise as possible. That level of precision is really powerful. Raphael, what do you think?
Can I open up my laptop to write notes?
Yeah, well, fine, sure. I don't mind, I guess. What is that? Yeah, you're right, sorry, Kevin. So it's array, our input. The first thing that goes in our local memory is not output as an empty array, but array is now populated with 1, 2, 3. We're not running hypothetical code here. We are literally live in our code going through line by line. Everything has a value. Array has a value of, one second, Jessica. Array has a value of 1, 2, 3. The array 1, 2, 3. So let's put it in. In our local memory, array is now 1, 2, 3. Jessica.
Just to clarify, as the computer is going through the code, when it first encounters the function before it's actually been invoked, does it store the function in global memory, or does it wait for the function to be called for it to actually be stored?
What do we think? When we see the keyword function, when we define a function, how would we be able to access it later by its name if we were not putting it right there in global memory? So Jessica, absolutely, when we encounter a function's definition, the whole thing stored in memory so that later on, we can only refer back to this function by name because we stored it in memory under that label. So it's there in memory. Good clarification, Jessica. So let's keep going. Kevin, race us through inside this function. What's our next thing we do?
It also stores variable output as empty array.
Empty array, thank you. I'm going to put these over here because we're going to be working with them in our thread. So array 1, 2, 3, just for visual purposes. And output is an empty array. What's our next thing, Kevin?
Runs a for loop.
Okay, so we are playing the interpreter. That means we don't sort of say hypothetically. We're going to iterate through our array that we passed in. On our first iteration, I is 0. Keep me going, Kevin.
I is 0, and then it looks. The next line is output dot push.
Let's be really precise. Oh, sorry, we're here. So I is 0. We're now inside the body of the for loop. I is 0. Let's go sort of work our way out. So I is 0.
I is 0 multiplied by 2.
So what is array at position 0?
Array position 0 is 1. 1 times
Right.
2.
So this portion here, the I is 0, and so that's the 1, right?
Yes.
And then we're going to take that and we're going to multiply it by 2.
Yes.
Which means now array I multiplied by 2, which is the number 1 multiplied by 2 is now 2, and that's evaluated to 2, and we're going to use the built-in JavaScript method push to push that 2 to the output array. Okay, so there it is. Okay, let's go through again. So now I is...
So now I is equals to 1. No, sorry, 2.
I is equal to 1, which means in the array it's position 1, the 1th position of the array, which is
Position 2.
so the number 2, perfect, and we do that number 2,
And then you push it to the output array.
so we multiply the number by 2, 4, and we push it to the output array. Boom, there it is, we do again, 6. Good. Now, what's the final thing we do, Tom?
And then you return that array.
We return that output array, out it comes, which means the execution of copy array multiplied by 2 with the input of 1, 2, 3 is finished. And if you remember our little call stack, it would have been popped off the call stack. We finished working on this level, which was inside this function. We go back to the global level. Everyone remember that bit? That's a very advanced thing. This is very impressive, you guys asking questions related to that. So we finished running multiply, whatever it was, copy array, multiply by 2. That is a disaster. All right. Copy, array, multiply. I'm writing this out only to be instantly arrays, unfortunately. So we finished running that, gone. And now we're back out into the global execution context. There it is. Which means everything in here, we lost it. But we didn't, because we had whatever output was as the return value. It's the word after the keyword return. So out it shoots out the bottom, meaning this whole executing of this function has become that output 2, 4, 6. That's our evaluated result. Now, how do we hold on to it? It's gone. JC, how can we hold on? Actually, JC, I've asked you this before. Amy, how can we hold on to the result of running this function? How can we sort of hold on to it so it's stored in memory? Exactly. Assign it to a variable. So assign it to a variable. Let's be precise with our language. So var results or something like that equals, and our result is that 2, 4, 6. That 2, 4, 6. Excellent.
Where does the assignment take place?
Oh, we didn't do it on the screen here because right here, what would happen to that 2, 4, 6? Can we refer to it as output? Could we refer to it as output out here? Charles, can we refer to it as output out here?
Yeah.
Oh,
no, wait, no.
Well, let's have a look. We can really be very procedural about this. Let's go look for output. Is there anything called output in that global memory? No.
You could refer to it, it would just be a different variable than that. I mean, it would just be different than what's inside the function.
Have we declared something called output? Jen?
Well, I mean, if you created a variable called output, you could create a variable called output.
We could create a variable called output, but it wouldn't be referring to the one inside of here. So when you shoot it out, it's fine because the execution, the running of the function becomes the output of the function, and we can just store that as a result. And so we said now it's sort of result, but otherwise it just goes out into the ether. Clear, Dom?
Well, yeah. So you're saying that you're going to say, let's say it's returning output, and you're putting it into a variable, but that would be done outside the function.
Because the execution of the function, this portion here becomes whatever, when we run that function, is after the keyword return. Whatever which is output, which was 2, 4, 6, the whole the running of the function, this bit here, becomes that output. So when we write var result equals, we're saying, go away and do some work, run this function with this input, and whatever's after the keyword return, which is output, which is 2, 4, 6, pop that out the bottom of the function, shoot out the bottom, and store it on whatever the left-hand side is, whatever label's on the left-hand side. That's how we do it. All right.
Wait, so that would be, so the last line there outside the function, you put the var results equals that.
Don't swallow. Great job, man.
Would then that be in the global memory? Yes.
Yeah. Jen's absolutely right. Jen's spot on. Excellent. Good. Okay, now, let's have briefly thumbs on this idea. You lost me long ago. I have some clarifications. I am so clear and I'm racing onwards. Okay. We're going to keep moving. A high five over here. Do you have a clarification, Raphael? No, you're good to go. All right.
Wait, then one big down vote.
We'll jump onto these guys a little bit later on, Joe. All right. Now, what if we wanted to copy array and divide each element by 2 this time? So taking an input array, take each element, divide it by 2, stick it in a new array, and return it out. How would we do it? Looks remarkably similar. Our code looks remarkably similar. But let's quickly race through it to make sure we're clear. Oh, okay. Let's not race through it. We know what it is. It takes in, let's talk through it. Copy array and divide by 2. Takes it, we run it with input 1, 2, 3. So array is 1, 2, 3. Output is an empty array because we're running inside a copy array now. Divide by 2. Copy array and divide by 2. Peyton actually talk me through inside of this function. So output's an empty array. Array is 1, 2, 3. What are we doing? Just talk me through high level what we're doing here.
Okay. We go to a for loop.
Yep.
Through each iteration.
So through each iteration, really loud for our online viewers.
So through each iteration, we are.
Peyton, you're famous. You're being heard around the world. I'm hearing there's people in Brazil, in Saudi Arabia.
Okay.
You're famous for all of them, so volume.
So through each iteration, we are adding the array of the.
So position. Let's maybe just keep it simple. Our position I is 0.
Yeah.
Which element do we take?
We take the first element.
Which is
1.
Great. And what do we do with it?
Divide by 2.
Divided by 2. So what comes out?
And then we add it to.
Well, what's 1 divided by 2?
Oh, 1/2. I mean.
0.5 exactly. And what do we do with that 0.5?
We add it to the. We add it to output.
We push it to the empty output array 0.5. Great. And then next time I is 1 because we're looping through each time, incrementing, going up I. I is now 1, which means we grab position 1, which is 2. Divide by 2, we get 1. We push it to the output array. Then we do it again with 3, 1.5. Now our array output is now populated with 0.5, 1, 1.5. What do we do with the Peyton?
Return it.
Pop it out the bottom of the function. We return it out of the function. So now copy array and divide by 2 with the input of 1, 2, 3 has become that output 0.5, 1, 1.5. Out, it's popped out the bottom. It's become that, and what do we do with it? We don't do anything with it. What could we do with it? Alejandro, what can we do with it?
Store it in a variable.
Sweet, Alejandro, that's she's spot on. My favorite question with my favorite answer. 0.5, 1, 1.5 is now stored under the label result. Okay, now, what if we were to create a brand new function? Copy array and add 3. This time it takes in an array, it iterates through it, adds 3 to each element, and pushes each element to a new array and returns. Anybody notice we are getting, what principle are we breaking, Alejandra?
Dry.
Yeah. Alejandra says we're breaking the dry principle. She's right. What can we do? All our code here is the same. New output array, take an input, iterate through the input array, take each element, do something to it. The only thing that's changed is what do we do to each element? A little bit of functionality. That's all that's changed each time. But we're creating a brand new function every single time. Tom, lucky day. What could we do if we just change a little bit of functionality? What do you think we could do to make this more general? This function just apply. We have to create a new function every time. We can somehow, when we run the function, do something else.
Add in another argument.
Another argument, another input. And what would it be?
I guess it would be subtract, multiply.
So we could generalize our function and decide only when we run the function what we're going to do to each element. Are we going to add 2? So we can pass in that functionality as an input, so we can have a placeholder. A placeholder, maybe call it instructions, that when we run the function, so copy array and this time manipulate, we know what it's going to be, taken as an input, a placeholder, and then only when we run the function, fill that placeholder out with an actual function, multiply by 2, and then apply that placeholder, which is then multiplied by 2, to each element of the array. So before, we said, take each element, add 3. Take each element, divide by 2. Brand new function each time. Now we say, take each element and apply some instructions to it, which is a function. It's a function, and we're going to decide, it's a placeholder. When we define the function, we don't know what it's going to be. But when we run copy array and manipulate, we fill out instructions with an actual function. Because when we want to do some functionality, we bundle it in a function. In this case, we bundle it in the function multiply by 2 and pass it in as an input. All right, we're going to walk through this code line by line. This is our client, this is our everything. So let's go through line by line. Raphael, this is your lucky day. Let's go through. What are we doing? Line by line. Let's clear this. What are we doing line by line, Raphael?
Alright, so the interpreter will go through and store copy array, the function.
Can we pull the door to a little bit? The Codesmith drinks and celebrations have begun. All right, thank you, Owen. Yes, sorry, Raphael.
We're going to store the function copy array and manipulate.
We're going to store the function copy array and manipulate in.
With 2 parameters, array and instructions, into the global memory.
Spot on. There it is. We're going to define a function copy array, manipulate, and its whole function definition is stored in our global memory. Got it. What's our next line of code, Raphael, that we're going to encounter?
The execution statement.
Is that the next line of code? Is there something else before?
Oh, actually, there's another function, so we're going to store that.
Another function definition, which is?
Multiply by 2.
Okay, so we've got a new function called multiply by 2, and that's also being stored, the whole function, in memory. There it is. Spot on. Okay, and now what's our next line of code? What's the next thing we do? Try and use as sort of on-point language as you can, Raphael.
We are going to create a execution.
What's the thing on the left say first?
Oh, we're gonna create a new variable.
We're going to create a new variable.
Call the result and store it
Into?
Global memory.
Raphael's right. Raphael said we're going to declare a new variable, result, and we're going to store that variable in global memory. Okay. Raphael, what's going to be stored on the right-hand side? What's going to be stored under that label result?
A function.
Whenever we see our parens on the end of a function, our parentheses, that means JavaScript, go away and run that function. And whatever comes out the bottom of it, store that under the label on the left-hand side. Definitely have no sense that this JavaScript doesn't care about this function. It just wants you to go away and wants itself to go away and find out what comes out the bottom of running that function with these inputs. That is what's going to be stored under the label result. Definitely not the function. If we didn't have the parens saying go run me, what would be stored under the label result, Raphael? The whole function definition of copy array. The whole thing would now have a new label, an additional label, result. But it's not that. Instead, it says go do me, go run me, inappropriately put. Go run me. For the online viewers, there was a quiet murmur of laughter there. Copy array manipulate, now we're executing it. So what do, Raphael?
Now we are going to create that stack trace, or local stack trace of memory.
Yeah, we're just going to start executing the function, so we create a little brand new execution context. Maybe stack trace is maybe an appropriate term, but copy array and manipulate is now being executed, run, and so we've got to create a brand new execution context with its own little local store, little local memory, and we're going inside the function basically. You've got to go inside the function and get something out the bottom. And that's what's going to be stored under the label result. What's here now until we get the result? What does JavaScript temporarily put here? do we think?
Oh, undefined.
Yeah, very good. Yeah, undefined. Huh. Nice job. Yeah, exactly. Undefined. So copy array, manipulate with the inputs of 1, 2, 3, and multiply by 2. That's what we're running. In we go. We have a little local memory. There it is. What's the first thing in our local memory, Raphael?
The parameters, array, and instructions, which are the passed-in values.
Which are?
An array of numbers 1, 2, 3.
Yes.
And function multiplied by 2.
Exactly. We've defined the function copy array and manipulate. We've said when you run me, fill out my inputs with some actual stuff when you run me. So array is filled out with, when we run copy array and manipulate, 1, 2, 3. So now array is 1, 2, 3. Inside of this function, wherever you see array, it's now 1, 2, 3. And instructions is filled out with the whole multiply by 2 function. Wherever you see instructions inside of this function, you can just now, because we're running this function copy array and manipulate with the input 1, 2, 3 and multiply by 2, they've filled out the placeholders, meaning instructions here is now multiplied by 2 when we're running inside of this function here with these inputs. So, exactly as Raphael said, the first thing, array, is 1, 2, 3. And the next thing, instructions, is, we've said, what is it?
Multiply by 2.
Multiply by 2, the whole multiply by 2 function. The whole multiply by 2 function. Meaning, if we ran instructions, put parens on the end of instruction inside of this function, what are we really running, Raphael?
The function multiplied by 2.
That's everything. We are running the multiply by 2 function. Okay, so let's go through our code line by line. Raphael, start us off at the top. What's the next thing we do?
We are going to create a new variable named output and initialize it as an empty array.
New variable name output, initialize it as empty array. Very nicely put. Let's actually put our array here because we're going to be playing with it. And our output here as the empty array. Okay, next line. Let's have you... yeah, Raphael, keep us going to the next line. So I starts as 0. What happens?
So the first time through, I will be 0, and
Yep.
we're going to check to see if I is less than the length of the...
Yeah, we can hold with how the for loop works specifically. So you're right, I is 0, which means which element of our array do we grab?
The first one.
The 0th one. The 0th one, which is?
1.
A 1. So we had our array, it says array I, with I is 0. So we grab the 0th element, which is 1, and what do we do to it?
It just executes it and it's replaced by array.
Yeah, so let's be really precise with this. So it says, take the 1, which is the item at position 0. I is 0, array is now 1. Meaning this little portion here is now the number 1. And it says, put that as the input into instructions. And Alejandro, what is instructions at this point? Let's look at our little local memory. What does it say it is? It's multiplied by 2. Actually, let's just put multiplied by 2 above it. It's sort of not really, we don't want to refer to it as multiplied by 2, but that's what it is at this point, because we're running through and we filled out instructions. Remember we had array and instructions as our inputs, and we filled out instructions with multiply by 2. That's what it is inside of here now. So we're executing a new function. What do we do when we execute a new function, Alejandro? What do we create? A brand new? That thing. Execution context. Alejandro's right. There it is. Let's create a brand new execution context. And when we go inside, what are we really running here, Alejandro, again?
Multiply by 2.
Okay, and so let's look at the multiply by 2 function. What is the first thing we're going to store in the little baby, even smaller local memory? What's the first thing that's going to be in there, Alejandro?
You're going to assign the number 1 to input.
She's spot on. Input is 1 because we're really running this function, and this bit here, array I, became 1. And then it goes as our input, and so we have input is the number 1. Perfect. And so when we hit the next line inside that function, which is what we're really running when we run instructions, it says input by 2. We do input by 2, which is really 1 by 2, which evaluates a 2. And what do we do with it, Alejandro?
Return it to the other function.
Return it out. There, out it pops, 2 pops out, which means this whole portion here, instructions with the input array I, which was 0. I was 0, which means we grabbed the 1. And then we said 1, put that as the input into instructions, which is really multiplied by 2. This whole portion here now evaluates, so the output of running multiplied by 2 with the input of 1, which is 2. And what do we do with that 2, Alejandra?
You add it to the output array.
We apply the push method. We're going to be so precise here. You're right, we add it to the output array, exactly. But how would we say it really precisely?
Push it to that.
But yeah, we push it to that. We apply the push method, the built-in push method, and push that to. Beautiful. There. Okay, perfect angle here. Push that to the, there you go, output array. There we go. And then we do it all over again. This time I is 1, which means we grab the 1th element, which is a 2. In it goes, we run. Oh, by the way, when it returned out, this thing died, right? We create a brand new one. When we start running instructions the next time around, create a brand new one. Oh, there we go. Brand new one. In the input this time is 2. Out pops 4. Now we put 4 over here and then 6. And then what do we do with Alejandra?
You return the value of output.
Yeah, she's spot on. Out it pops. 2, 4, 6. 2, 4, 6 is the output. There it is. So our execution of copy, array, and manipulate with the input of 1, 2, 3, and instructions being replaced by multiple by 2, the output is that 2, 4, 6. Now what do we do with that, Alejandra? It's gone into the ether now, hasn't it? Or are we going to do something with it?
No, you're going to assign it to result.
Exactly. So what was undefined on this side right now, we've now gone off and done our work. And back came our output, whatever was after the keyword return, which was literally the output variable. Out it came 2, 4, 6. This whole portion here, the whole execution of this function, this whole from here to here, is evaluated to the output of running it 2, 4, 6, and we stick it under a variable. There it is, var result, and so now result is that 2, 4, 6. We have achieved exactly the same as we achieved with that function, copy array and multiply by 2. But this time we said pass in as the input the multiply by 2 bit, the multiply by 2 functionality, and only decide it's going to be multiply by 2 functionality when we run copy array and manipulate. This is very, okay, good. At this point, we're going to have thumbs on this absolute core concept of running our function, copy array and manipulate, and only when we run it, passing in as the input the functionality to fill out the placeholder of what functionality we're going to apply to each element of the array. Let's have our thumbs out on this concept. I regret even attending this class. I have some clarifications. I've invented new versions every time. I have some. They don't want to say that now. They're like, I can't be found with thumbs. I don't want to say regret. I have some clarifications. I'm clear and I'm ready to move on to the challenges before we come back and wrap this up to explain how is this possible in JavaScript and which of these is our callback and which of these is our function. Everyone's thumbs out. Clarifications? Clear to go, and you lost me at the beginning. Everyone's thumbs. Alright, anyone want clarification? Any clarification? You have a clarification, dude?
What's I++?
So on that note, I think we'll come to that separately because the for loop bit is a little bit more fundamental. We'll come to that separately. But in 2 words, it means this line here says everything inside of me. So this portion, this line, output.push instructions array I, do that line as many times as the length of the array. So if the array is length 3, do that little line inside 3 times, and each time, the first time I is going to be 0, the next time I is going to be 1, the next time I is going to be 2. And that idea of iterating through data, a loop, is a fundamental principle in programming.
So this stops at 2, right? So is that how it works?
You spot on? That's what we want though, right? Because the arrays are what's called 0 index, so we want to grab the 0th element, the 1th element, and the 2th element. Hold on for a second, all right, son?
Peter is a little unclear as to...
Online question. This is a big moment. Shout out to Peter. Thank you for invoking your right to ask questions from online.
He just wants to clear up what value is passed into input in multiply by 2? Is it the 1, 2, 3 array?
Well, let's have a look. So what is actually inside of instructions, which is really multiply by 2? Well, I is the first time. What is I the first time, Will? 0, which means array I is, array 0 is 1. Exactly. Regrettably, put the wrong finger on that point. Array, exactly. So then the answer is, what is passed into instructions, Will? Is it the whole array or is it something else?
1.
It's the exactly the north element, the 0th element. Another Britishism, naught means 0 in England. It's the 0th element, which is the number 1. And then we loop through again, and this time it's the number 2, because it's the 1th element. And the next time it's the number 3, because it's the 2th element. All right. Yeah, I think saying first, naught, anyway, we get it. Good. Sam, that clear it up for Peter?
I don't know, it's only like a 10-second delay. We'll know in time.
Perfect. Okay, at this point, everybody, we're going to go back to our pairing, and then we're going to reconvene very soon to say which of these is our higher order function, this most esoteric of concepts, or not. And which of these is our callback, and how is this even possible? All right, back to your pairing. I think I've turned my volume up significantly. It's got to be louder. It's getting
Oh, you did talk. You did. It's the same thing. Oh no, actually.
and choosing something.
I know that's how it works.
You already have it. Do it.
I feel like it's just like a little thing.
It's your first time?
Because like the initial value is like essentially the accumulator of what they refer to, wherever they refer to the accumulated value, you can just set the accumulated value as your initial value and accumulate that every time you get it. Let me try it with forEach. See if that works. Any different for us.
That's good. What's wrong with you? What's that? Oh, for 2 years already. Hey Kyle, what's the website name called again?
Oh, we have it.
So pretty easy. We can skip to the more harder.
Yes, I think it's every righteousness.
word stretch. So we have the array. So the array represents this right there. We have our current node. Oh wait, that's what they're wrong.
It's okay. We'll just say we did it. Now we want to load, so do the combo here.
Excuse me, sir. We have a question. I just mean like so we're working we're doing reduce, and we have two separate ones. We have like we did it the for loop way, and then we did it the for each way. Both times we're only getting 0, but I feel like they're pretty spot on. So is there just something where we did like an error or like a little tiny something that you look at? We're just getting 0 back. It's not perfect.
So let's see what we're using forEach here.
So we have both of them. We just talked about that. So we essentially have.
Let's start with the one you have commented out.
Let's start with that one.
The initial is you're looping through, and we're saying initial value equals callback array.
So now, like, so callback is our add. Oh, that callback
Well, real quick, so you're calling your callback with one of the values in the array and with the initiative. So what you want to do is you want to think about calling the callbacks just the one value of the array. And produce, you want to think about it as like we have this array of numbers you can bring in one value.
Oh yeah, no. The initial value is every time you run the callback or you iterate through the array, you apply the initial value, so it's stored. So it adds on so by setting, so then when you're done iterating through each item in the array, you set all that as your input value before you set the value that you're getting your we keep it zero, which is just returning like the initial zero. So it's like it's not even running, nothing even.
Do you know what they're plugging in there?
Yeah, I'll show you. They're giving us they're passing it as callback. It's like pretty straightforward, so I'm not confused how it's not. I try to. Oh, the result. No, so I'm like confused.
What is the initial value?
Is there an error?
Oh, yeah, there is one.
What is it telling me?
Good spot. Could we add in these challenges? Which lines do we need to cover? Which lines do we need to delete?
Yeah.
Which lines do we need to comment out? Extension 1. Yeah. That should be called out.
Was that when you built the first Mac? The first Mac came up as undefined? Yeah, I mean, are you guys, you do this yet? You want to do this yet?
Alright, I'm not, just a quick interception.
Well, we have this session.
Just a very quick point. I don't know if this is something we always had, or whether we added a bunch of new extension challenges at the end of last week. But if you're struggling with map and it's not actually doing anything, you need to go down to the extension 1 and comment out the other definition of map. Now, I'll say this, others have managed to debug that successfully. But you might as well just fix it right now. So comment out the map definition in extension 1 so that you can get your map working before you get the extensions. All right, back to your pairing. Go down.
So then the third iteration, it becomes 3, 3, 5, and 8. And then you set all of that equal to the
Logic is not. Can we throw a console log in here and see what happens?
No, that's what I'm saying. It's there. The console log is there.
Why don't we put a console log inside the for loop and just log the initial value inside so we can see what's happening?
How many 6 words?
No, they have to write it here.
Yeah, I should. So then, what else
it's like an inside or something.
We need to
It's
actually.
not long.
Because that's how it works. I know
Go ahead. The wave 2 that we return is this. What is this, right?
Can we, the console log that was like the narrative thing they have set up?
Well, I guess it can.
Oh, okay, so what you do here is you look at what is it asking for? So actually put this outside. Let's actually use the same
So let's take out the console log here, but just use the regular initial value, then separate from that, why don't we console log on top of that, so we can start like investigating. So let's see what's happening with I, and see what's happening with the
You're saying take out that initial value?
So leave that line of code, put up the console log on top.
This is the explanation we just had about
The crucial word.
So let's see what the initial value is each time we go through the loop. So we should get that's an initial value.
new array, both the numbers that are the result is a callback function.
I feel like it's just
Alright everybody, I hate to disturb the buzz of pairing. I really do actually, because it's a real energy right now. But we're going to close off with a few vital additions. How is this even possible? And a few other bonus things. Thank you, Alex. Close the door too. Oh, are you making margaritas? What's good?
I only made one. Red alignment.
Whatever, make me one as well, my friend. Alright, good. So everybody's laptops too for this final portion. Sam, are you going to get the online phone back on?
Yeah, I think there's
Bring them all back into the final piece. Alright. So, who comes from a non-JavaScript language background? Alright, so I'm another language, not just not JavaScript. Like, that was unclear. You come from another language like C or Java, Python, Ruby. This may seem very strange to you. Actually, Pablo, do you mind moving back a little bit? This may seem very strange to you. This idea of passing in as an input into a function, another function as its input. That's in some languages very unusual, very impossible even. In JavaScript, it's possible because. Charles?
Oh, sorry.
In JavaScript, it's possible because functions in JavaScript are what's called first-class objects. That sounds profound. All it means is they are objects. Actually, in memory, they're stored as objects. They have all the characteristics of objects. They can be stored as variables, as properties on other objects. What are functions that are properties on other objects known as? Do you know, Tom? What do we call them when a function's in an object? Method. Exactly. They can be passed as arguments into functions. That's what we saw here. We passed as an input into our function another function. That's possible because we can do that with objects. We can certainly do that with functions in JavaScript. And they can be returned out. We could have returned out a function as our output. Now that's very profound. That creates something called closure my favorite concept in the whole of JavaScript that gives our functions memories. And that is JavaScript, the hard part, part 2, closure, the idea of returning functions out of other functions. So, then the question becomes, which of these is our callback and which of these is our higher order function? Jason, what do you think? Which of these is our callback and which is our higher order function?
Copy array and manipulate is the higher order function.
Jason's spot on.
And then copy array and manipulate is the higher order function.
Yeah, Jason's exactly. That's our higher order function. Which here is our callback function, Henry?
Instructions.
This most esoteric, profound, higher order functions. All it is any function that takes as an input another function or returns as an output another function. Here we saw it taking as an input a function. We don't have to tell it to be a higher order function. By definition, it's a higher order function if it takes as an, and all functions in JavaScript can be it. As long as it takes as an input another function. Any function that gets passed in as an input and then used a little bit later on, you might want to say called back. That's where the name comes from. That's our callback function. Any input function is our callback function. And that's it. That's it. That's the most profound portion, but that is it. The function we pass in is our callback function. The outer, the host, the big function takes in the little baby function. The big function is our higher order function. The little baby function that gets passed in, that's our callback function. Yeah, we know this. So, callbacks and higher order functions, they keep our code dry. Do not repeat yourself. We created one function called copy array and manipulate. We defined it, and then when we ran it, that was when we decided, only when we ran it, we decided to fill out instructions with multiply by 2, but we could have filled it out with divide by 3. Add the string s to the end of each element. Every single element in the array will be hit by whatever we pass in, whatever we fill out the placeholder instructions in our definition of the function. When we execute that function, it gets filled out with an actual function, multiply by 2, divide by 3, add 4, whatever. We've made our code dry. We've created one big function, copy array manipulate, and then we just create lots of little functions to decide what we're going to do to each element. So no longer do we have to create a brand new function, copy array and add 3, copy array and divide by 2. They're all in there, ready to go, and we just create little baby functions to say what we're going to do to each element, which we decide when we execute the function. But I use something even more powerful in JavaScript. In Node on the back end and in our JavaScript on the front end, they allow us to run asynchronous code, which is the backbone of the modern web. But that lies in the Codesmith program, and therefore, unfortunately, it is late tonight, and therefore we will not go into asynchronous programming. But you now have the pieces of callbacks and higher order functions. So, very well done. No, I have a strong principle, no rounds of applause. You should be proud of yourselves. But I have two things to add. One, thank you to all of our wonderful online viewers. We are thrilled to have you on from places as far-flung as Lagos, as Argentina, as Brazil, as far-flung as people in Los Angeles who are not willing to drive to the in-person jobs for the hard parts. You know who you are. San Francisco, many from New York, and we are so thrilled to have them always online with us. We didn't shout any of them out by name tonight, but round of applause and a big hello from the entire on-site community here. Round of applause. One, I brought my trusty prop here that I have sipped from, Ruthless Rye IPA from Sierra Nevada. You don't get these lie in my fridge. You get Tecate and Coors Light, but you are very... Boo. You're the one who put them in the wrong fridge. You're very welcome to go and try and find them in another fridge, but these come for drinks afterwards. I know many of you want to keep pairing. Go grab drinks, come back and pair. But I have one other thing to add. I have one thing to add. That is, we are now at, and you probably saw a few people be pulled out of tonight's session. Tomorrow is the last day where you can be accepted into the June 20th cohort. We've had now about 175 applications for the June cohort, and I believe we've made 14 offers now. The maximum we can make is 20. We've made 14 offers. Tomorrow there are something like 7 interviews scheduled, maybe 8 or 9, all back to back. But if you, we discovered, and some of those people, by the way, are in this room, and good luck to them. Tomorrow is a big day for them, so very much good luck to them. We discovered that around 90%, I think is realistic. Now, maybe today somebody was accepted who didn't attend JS at Hard Parts. He watched a recording of it but didn't actually attend it. But it's very rare. Something like 90% of all people accepted the Codesmith have attended JavaScript the Hard Part, because as I said, much as I hate explaining by analogy, it is an all-round muscle workout for the things we look for in interview. Analytical problem solving with code, technical communication, non-technical communication, debugging how you encounter hitting a block, and your JavaScript or programming language experience. So, because the online application, about 40% of people who apply through the online regular application are actually invited to interview, and the others don't make it to interview, we created the JavaScript the Hard Parts Challenge, 24-hour challenge. That is a technically a little bit more demanding challenge that if you complete by 11:59 p.m. the next day, you are automatically invited through to the Codesmith interview stage. So rather than being a 40% chance, you will automatically. Will we do this forever? I don't know. So far, it's we do it because the people who come to JS Hard Parts are the Codesmith type people, and we do also watch how you pair, which we probably shouldn't tell you, but we do look to see how you pair in JS Hard Parts. So it has a special code, and it's open until 11:59 p.m. tomorrow. And if you were to complete it tonight and schedule your cultural interview tomorrow morning and your technical interview tomorrow afternoon, it is still possible to be accepted into the June 20th cohort in an unprecedented flurry of final day activity. It has a special code, which I wrote on my hand, of all places. Here we go. So, here's the code. If you pass this challenge by midnight tomorrow, codesmith.io/hardparts/MGEZ. There it is. If you pass this challenge, you're automatically invited to the Codesmith interview for, if you can go crazy fast, June 20th. Otherwise, the next cohort, I believe, is August 2nd, I believe. It builds upon what we did today. Very good luck. And, oh, please don't share this outside of the JS Hard Parts community, because the purpose of it is for us to be able to see how you pair together. And because people who attend something called the Hard Parts are a certain type of ambitious, driven, and good person. So, there we go. Back to your pairing. If you want to grab some drinks, you can hear the joy of the Codesmith students out there celebrating.
What's the last letter?
Oh, Z. Z. Z, there we go. Z. The Codesmith students tend to stay here until about 11 p.m. or midnight every night, and so Thursday is their evening to let off steam. So if you want to go and have fun and join them, you're very welcome to, or grab a beer, and then come back and keep pairing. But otherwise, back to your pairing, and very well done tonight. Okay, back to your pairing.
You guys get the bar?